Good morning, all. So today we are discussing about our project from Group 23. Myself is Yuvraj Jami, and my friend. I'm doing this project along with my friend Karthik. So the concept that we're going to talk and discuss about is collaborative filtering in restaurant recommendation system. So this is our project. Uh, so when it comes to the problem statement, so we know the food delivery system has been growing day by day. So we are going to do a recommendation system that actually helps the existing restaurant recommendation systems, which have been employed and been used in the day-to-day life. So with respect to the core objectives related to this project, we're going to examine the restaurant future and user preferences, like using the location of restaurant and the type of menu they offer, and the kind of surroundings with surrounding contextual features like traffic and weather. And we're gonna see how the existing recommendation system works. So this is the workflow diagram of our project. So we're gonna collect the data which is available from Kaggle. We're gonna pre-process it. We're gonna do exploratory data analysis to that pre-processed information, and then we're gonna try and test the model that will eventually generate a recommendation system. Eventually, those results can be utilized to do visualizations. And finally, we can able to see the conclusions of an updated or enhanced recommendation system, which is kind of more accurate than the existing one. So that's the goal of this project. So the data set collection is, as I mentioned, it is from Kaggle. So it has a lot of contextual features like weather and traffic density present in a location, to be precise, in a region, and certain key features like user ID, restaurant IDs, and then the ratings associated to the restaurants are also being present in the dataset. We are lucky enough to get a good amount of sample records, about 10,000 records. So that is a good amount of data in order to test and find the accurate version of the model. So these are the methodologies that we have implemented in our model. So a user-based collaborative filtering, something that uses ratings and users as a core thing, and the item-based filtering. So it is based on the user ratings as well, and the singular value decomposition, which uses maximum factorization based on rating predictions, and an enhanced SVD with contextual features. So the contextual features like weather and traffic information, and then the city data will be present. And finally, we have the evaluation metrics of RMSE and MEAE. Uh, so these are the set of methodologies that we're going to incorporate, and we're going to use the data processing techniques to avoid any missing values or outliers, and followed by the future engineering. So these are the three future engineering tasks that we took up, which is very much specific to the recommendation system, and the results associated to them we can see in this thing. And the data cleaning results. So how the data looks like post cleaning. So these are the cleaning results, which you can able to see in the detailed Colab file. So it was standardized, it was cleaned properly, and then it was sent to the evaluation, and we got some evaluation measures. You can see we have done multiple evaluations, and the results were pretty much approximately close to one another. So you can see they've been tested in multiple folds, and the results associated to that. And moving on to the further slides, which is related to the visualization, my friend Karthik will continue from here.
Yeah, coming to the visual insights, we have performed some bar charts and the histogram charts. As you can see in the charts, like the numbers going from the accurate results of based on the model performance and the distribution of ratings from the rating values. And co- and coming to the visual sites from the heat map, this is a heat map, which are we have favorable conditions like high ratings, and the adverse conditions like low ratings, and the moderate conditions are stable ratings. And these are the values that you can see. And coming to the recommendations, with the when the user is an ID and the top meal is like top item is meal and the predicted rating is high, whereas the clusterings are like the predicted ratios, and the clustering visualization highlights preference based on segmentation. And coming to the impact of contextual features, whereas we have observed some similar ratings like high, lower, and the RMSC reduction with contextual features like snacks or drinks. And coming to the conclusion, whereas we have some in brief contextual performance which are noticed in the baseline methods, and the accurate customization is very important in the contextual factors, whereas the restrictions are like no real-time changes and the static contextual data. For the upcoming projects, we need to some examine like hybrid models.
Yeah. So the thing is, like, we have kind of with set of restrictions that we have chosen a static data. It is available from Kaggle. But if we take a real-time data using Google Maps APIs or even from Elp, so that can able to we can able to generate a dynamic responses as well. But since we are limited with certain resources, we thought of going with the static data. So that's the core concept. And then these are the contributions. So we have divided the entire project pipeline, and then based on that, we've worked equally. So equal amount of works were distributed, and our
Yes.
project references. So we have kept the references, and then these are placed with respect to the IEEE format, followed by yeah. So this is the paper that we have created using Overleaf. So the we used an IEEE format paper, and whatever that we have discussed so far related to the methodologies, the background of the project, as well as how the pre-processing happened, and what sort of results that we have achieved in it, and what sort of evaluation metrics that we have followed, and the results associated to them, as well as the so we have done numerous visualizations, which we will show you in a while. But we thought like the heat map sums up everything, right, Kapil? So so that's the core reason why we have placed heat map, and then followed by the ethical considerations, and then the rebuttal conversation. And we have even kept the argumentations that we're going to discuss, further. And even we have concluded how we have summed up. And then this is about the recommendation result that Karthik has discussed a few minutes back. And then the IEEE references related to the project. So if I go to the PPT, the IPMV, so this is how we set up the environment. We just tested. So this is the original test and prime data sets that we got from Kaggle, and you can see this is before it is being sent to the cleaning process, and you can see this is trained data set. So during the pre-processing of data, so the methodologies associated to the Panda libraries. So we have certain features like there has to be some certain updates that need to be done
Yes.
with respect to the date format that have been done. And then you can see this is the prime data set post cleaning, followed by the test data set post cleaning, after cleaning. So you can see. how it is there. And the future engineering results. So we have imported certain libraries from math library of pandas, and that uses this specific formula. Uh, and the futures, the contextual attributes that we have in our data set, like, the distance kilometer, and then they will be calculated, which I have shown earlier in the PPT, like the three core aspect, distance, and then the latitude, longitudinal features. So those metrics which I have stated in the presentation, so we have calculated them and the results associated to the future engineering. And then some filtering results. So this is a very good library from scikit-learn called Surprise,
Yeah.
which actually helps for the collaborative filtering model. And then this is how we have, there is a sample evaluation of the metrics. But as I mentioned earlier, we have done multiple evaluations. This is the first sample of it. And then evaluate recommendations, right, Karthik? So
Yeah, this is the evaluation recommendations.
so it
There are
uses
lots of key lambda and
yeah. So it uses this method in order to try and test the data sets.
the
So
recommendation methods.
yeah. So post it was trained and tested, it will generate a result of top recommendations, as Karthik stated.
As we have discussed.
Yeah. So this is the
User ID
restaurant ID. Yeah.
and the
And
item
then
meal and the predicted values as shown in
yeah.
the result.
Yeah. So once it was done, so it was then further analyzed to calculate.
For the precision and the recall.
Yeah.
And yes, for the average precision and the recall is 1 approximately. As we have discussed the recurrence analysis for the cross validation.
These are the cross-validation values.
These are
And then we have compared with the baseline one. So this will take some time because it will test each and every column associated to the ones that we have mentioned. So it uses KNN algorithm basically. So it will take approximately like 5 to 7 minutes to to recheck everything and then to produce this result. And
this
then
is comparison between the RMSE cross models. And these are the types of graphs which we have got.
And finally, once again, we just cross-checked for any change of recommendations, but it was the same. Again, we have tested and trained the model, so we got a clear idea about how it works, and then the comparisons were made. This time around, we try to bring up even clear distinction. So this is the blue ones is RMSE, and the orange is
That's
ME.
not MA.
And then the distribution ratings, actual versus predicted.
With context and code.
Yeah. And the heat map.
Heat map.
And then finally, we have done some cluster admin. So this entire detailed documentation is present in IPNV. And those results have now been uploaded to OLIF as well. So moving on to the
counter.
The counter argument session. So I think we have to discuss deep into that. So okay, let's start with the argument session that we've been excited about. So you want to bring up something?
Yeah. So let's discuss about the first counter argument. As the inheritance based on towards the popular items like collaborating, filtering, The arguments are popular items frequently received with priority, and the limited of assistance consumers is like the finding the variety of options based on the service of the restaurants regarding the food items and for preserving current popularity.
So that's a good point when it comes to an argument like you have a collaborative filtering mechanism, but usually, as you stated in your argument, that it fetches only the top rated ones. I want to disprove in this context because yes, the algorithms have been designed in that way, right? They are much biased towards a problem. But implementing techniques like regularization or limiting the prompt diversity in terms of the recommendation filters, we can able to solve them. For instance, if you take ensuring a percentage of items which were available in the menu list, like the categories or unrepresented categories, the algorithms can able to balance those recommendations. So that's one of the example that I want to state with respect to your argument. Uh, but if you have certain evidence, you know that,
Yeah, like
yeah.
uh, like with the evidence coming to you, filtering models have been shown in the recent restaurants in the recent research, by uh, taking into account non-popularity and the weather and the SPD implementation showed that the addition to the contextual information additionally helped in the surfing and underrepresenting restaurants with particular items and the ratings shown in it before the customer goes into it.
So you mean like, I think, yeah, okay. So you mean like it is effective in terms of balancing the recommendations without compromising on the accuracy. It can be, yeah, it is possible. But yeah, I think it's a good start, for the evidence that you have stated for the argument. Okay, let's
And
move on to the, yeah.
yeah, coming to the second argument, as we have discussed earlier, the personalized recommendations are not worth then privacy risking, as there are some serious privacy dangers related to the collecting and assembling, assessing user data to support collaborating filter systems that may be broke into a personal information preferences and disclosed or exploited.
Okay,
Like
like, yeah, it is the whole thing, privacy is an important aspect when it
yeah,
comes to, yeah, the recommendation system or to in general, any system. That's a great argument. I can disprove that with keeping the quality of suggestions. Like, we have the privacy preserving methods, which can assure the security of user data, right? So, something like different privacy, you can remove the user data without sacrificing the performance of the model, right? You don't need a user data, in my point of view. But you can't completely remove that. Yeah, I agree to the fact that the model needs to be trained, the algorithm needs to be trained and tested. But we can add certain noises to the data set, something like the smoothing parameters, just to help the machine learning model to, behave properly. Because yeah, I know that if we ignore the user information, it will completely give a different results. But we can add certain noises to the user information when it comes to not violating the privacy factor of the user. So that's my disproving statement to that.
yeah.
And I can
But
actually,
for the regarding with the
yeah.
certain evidences shown from the research papers, like in the particular research I have done, like it has been shown that the putting privacy preservations of safeguards are placed successfully reduces risks and accurate in predictions that are made for the possible while user the data is protected. When these techniques are used like integrated into a collaborating filtering frameworks, we have seen some accurate uh, protecting sensitive data is crucial.
Yeah, that's what I've been trying to state. Because if you see something like, if you talk about sectors like, healthcare or banking sectors, right? So there the user data needs to be preserved at any cost, because particularly healthcare people are not going to discuss directly that,
Yeah,
showcase our data to everyone, because there has to be a privacy factor in that. So I think we're on the same page with respect to this
yeah.
thing. So we can disprove, but yeah, but we can disapprove this thing, adding a noise to it. But it depends upon the kind of data that we are dealing with. But yeah, we can move to the third
And coming
argument
to
that.
the third argument, in the lack of transparency of collaborating filtering, it reduces the user's trust. Like if you have like the relationable behind particular recommendations, which makes them mistrust the system. Like when we discuss about the challenging of the users of judge impartially and reliable of ideas, that due to the black box or and the nature of the algorithm such as SVD.
Yeah. So yeah, I think AI is something that people have been, concerned a lot about, because these days it is, going here and there, making the recommendation process to mistrust a little bit. But it happens sometimes where we can able to disprove this specific argument by highlighting the important or significant aspects, that influence the recommendation system, right? So we can do that. Setting up the user preferences or user ratings as a base parameter. I think we can able to deal with that. But because I would like to get an evidence for it as well, because on my
Yeah,
research, okay,
yeah. Like
so
for
we
the
can, yeah,
evidence, as we have seen some research, like uh, that it is an additional context such as the traffic and weather, increased accuracy and providing dimensions in the comprehensible, and it is an easy way to understand clarification whether which increased user trust regarding with the
recommendations,
accurate
yeah,
results
yeah,
provided in it.
yeah. That's what I would like to straight about, because even in my sort of thing that I've been researching about, I got on the same lines. So that's one of the things that I've been trying to bring on as well. So yeah, I think that's a good thing. Yeah, I think these are the three arguments, right, Karthik, that we would
Yes,
like to
yes, we have
discuss
this.
about, and yeah, and we've even placed them as well in the paper for a detailed, as a detailed summary, so that one can able to understand what exactly we're trying to bring on the table. And yeah, that's all from our side. So this is.
Regarding these
Uh,
differences, we have been worked a lot on the argument session.
Yeah. So that's all from our side. Thanks a lot for
Thank you.
having it.